Well, welcome everyone. This is our Wednesday webinar series. This is the second to last for the school year. We are so excited that you are here. We do want to make sure that you know that our last one will be on June 21st. I will be interviewing Dr. Liz Lubeski, who is the Director of Instruction of Educational Technology and Instruction in Manheim Central School District in Pennsylvania. She'll be talking about the best apps for teachers for 22-23 school year. So please make sure to join us. We'll be sending out that invite. Also for this webinar, after we're done, we will be sending you the recording and your certificate of completion. So be looking for that email probably sometime tomorrow. So with that, again, a very happy welcome to you, and I'm going to hand it to Chauntée.
Thank you, Corey. Hi, everyone. My name is Chauntée Pitts, and I am the Professional Learning Specialist for STEM Education Works. I'm getting ready to talk about one of my favorite topics, so sometimes I get kind of passionate, so I'm letting you know ahead of time. But I also really love talking about this topic because I usually leave with way more knowledge than I start with, because I have people who are willing to challenge or question. So don't hesitate to use the chat. We're monitoring it. Speak away, ask your questions, because this is how we collaborate and grow. So I'm really excited about it. So a little about me. Again, I'm the Professional Learning Specialist. I spent a lot of my STEM days in Texas, teaching STEM education and helping to work and write the curriculum for the district that I worked in. And I also have run the Governor's School residential program for Virginia. And I lived with marine scientists and engineer students who were pursuing that for a career. And I did a mentorship with them at NASA. So I'm really excited to talk about this. And again, I'm constantly learning and growing about this stuff. So, I mean, every day there's something new that's being brought to the plate because of new inventions or advancements in technology. So it's a really exciting topic. And I know that you're obviously interested in it if you're here with me. So thank you and welcome. So my objective today is just understanding failure. And I'm going to talk a little bit about ways that we can help our students go from feeling negative about failure to feeling positive and it being celebrated. And then I'm also going to walk through a lesson that is a science forward lesson in two different ways. I'm going to show you what a lot of people view as STEM and then another way of approaching STEM. So really quickly, I'm going to put this poll out there, but I want you to share your thoughts on failure and what that means to you. I am not going to be able to address everybody's, but I want to be able to see that later and read through it and see kind of the thought process that people have with failure. I know personally, it's something that I'm constantly running into. I want to be a perfectionist because that's within me, but I have been working a lot on, okay, how do I accept failure? And what does that look like for me in my growth? So just take a second if you can. And Corey, were you able to send that out?
Yes, it's on the screen. People are answering it right
now. Okay, thank you. All right, and I'm gonna let you keep answering that, but I'm gonna move to the definition of failure, which by definition, failure is the gap between an expected or desired result and what one ultimately experiences. And at NASA, they literally say the F word, if I may, is not used, and they want to call it early attempts at success. One of my favorite stories about failure is Dyson. James Dyson literally spent so much time trying and trying, where he was going to very, very minimal money, and he finally was successful after 3,727 tries. So that's just a view of what failure can do in finding the ways that don't work so you can get to what you really are hoping to get to. All right, so we're going to talk a little bit about the elephant in the room, which is a perfection problem. And education in general has an issue with that, both as teachers, we have that issue, and our students have that issue. And I taught gifted and talented, and let me tell you, I felt like I was just running into a wall over and over again with this concept, because if they can't do it right, they don't want to do it at all. And so how do we help them go from that to being willing to try? And again, it's a lot of leading by example, and it's scary. But I really feel like my students were willing to try if I showed them how I fail at the same time. So with that being said, let's look into just the different types of failures that are out there. So of course, academic failures, grades, those pressures to be the best at it or to get grades that are whatever has been set as acceptable grades. And then personal goals. So whether it's learning an instrument, learning a new language or a sport. And then you have social and emotional. And this is just students growing in their emotional intelligence, but also being able to make friends. And skill development, which is the basic skills that are essential to everyday life. So we talked about failure, but how do we help our students? So making time for failure. So setting your students up for failing. I have a friend who does failure Fridays in her classroom. And I'm always impressed with what they come up with for what they're going to do as their failure lesson. But give them the opportunity to do it and then celebrate it. Get excited about, hey, you figured out a way that doesn't work. So how can we go from here? Just giving them the chance to realize that it's actually a positive and not a negative. And of course, again, lead by example, share your failures, talk about your failures with your students, allow for them to see what it looks like in careers even. And I like to have questions like, what have I learned about with what I just did? Why didn't it work? And did I discover something new through my failure? And so I'm going to show you this, and some of you might have seen this before, but it's free on the internet out there for you. It's called a failure resume. And what I would do with this is that I would fill it out and I would post it up on the wall for my students to see stuff that I'm working on or stuff that I've tried. And then also encouraging them to keep a journal of their failures, to celebrate it and acknowledge it, and be willing to talk about it. So yes, if you want that, it's out there. You just search for failure resume. I know a lot of people, Elon Musk has one that he's sent out. You can find that out there where he talks through that. And it's just a great way for them to just stop and think about, okay, how is it impacting my behavior? How is it impacting my life? And then to help them overcome. So what we're going to do now is I'm going to talk just a teeny bit about science. And I'm not bashing the way that science is taught. I want to clarify that because I think it's a great way to, there's nothing wrong with the way science is taught, but I want to talk about the difference between science and STEM. So you have this cookbook method or step-by-step on how to complete a science experiment, which is awesome. We want them to know formulas. And this activity that I'm going to go through with you is incorporating the science concept, but also is considered a STEM lesson. So I'm going to go through the first one and just kind of walk through what is considered STEM. And I got it from a STEM website, the concept. And then I'm going to show you how I would teach it in a different approach. So the topic that we're going to focus on for it is force, motion, and energy. So I'm not going to teach you how to teach the content you're teaching, but just to give you an idea of what the focal point is of the activity. So for elementary, we're talking about potential and kinetic energy in this lesson. And then for high school, again, it's the laws of motion, understanding velocity and speed, and them getting a grasp on energy. So this activity can go all the way to high school in this whole entire lesson that we're going to go over. So this one is a traditional way. And again, this is one that I got from a STEM lesson that was provided me. What we're doing is creating a catapult to explore energy. So we would provide the materials for students. And then we would work through step by step how to create this catapult. So students would be looking at the pictures, looking at the lesson or the steps and creating their catapult. And this is, if you look around the room, you would see everybody's looking around the same. And then of course you would go over these content questions about, okay, what's happening? Did the ball fly where you wanted it to? Where did it land? What did you expect was going to happen? And that's for elementary. And for secondary, these are reflection questions for secondary students. There are questions that I gathered based on the content that we're talking about. So giving connection to the learning by asking questions like, why are you measuring time? What is the purpose of it? What is the relationship between kinetic energy, the mass of an object, the speed of an object, and getting them a chance to think about it as they're taking their catapult and doing the actual activity. So I just need you for a minute to just take a second and think about, is that activity critical thinking? Is that activity more teacher-led or student-led? Do you feel like your students would have a voice in that kind of activity? Is there a higher risk of failure? And do you think that learning is occurring in the classroom? Which some of the answers to these questions are a resounding yes. But I would love to take you on a journey of a different way of approaching this and still teaching the same content, but taking it on a different turn. So this is an approach to this whole lesson. And instead of saying catapult, I'm going to say launching device. And the reason for that is that when we say words like catapult, a catapult device, immediately that's what the students are going to start building, is a catapult. But if we say something like launching device, that could mean something different for everyone. So then it immediately gives their mind open to a creativity approach. So how I teach, people use different methods, but personally, I use the engineering design process. So I provide the question, I ask, I give them a chance to imagine it, they plan it out, they create it, and they're given time to improve on it. And this is a commonly used, some of y'all probably use this. If you do, yay, I love, this is again, one of my favorite approaches. So instead of having them build a step-by-step catapult, we're going to give the students a narrative. And this is the one that I came up with, but I have two different ones. One of them, this one is more of a simplistic one. It doesn't take it quite as deep as the next one I'm going to show you. It gets the job done. It's still exciting and inviting, and it's also relatable, except for those of you who don't get snow. So you could alter that as well. So you and your friends are planning a snowball fight, and your team wants a launching device, but you want to get out of the reach of the other people's launching. So how do you create a device that will reach them and give distance between you and the other team? So the ask for my students in this situation is, can you and your team design a snowball launcher to help you win the snowball fight? So I'm giving them something to relate to. And I'm also not giving them, again, catapult, but it's the same concept. They're still going to learn the energy behind it, but in a different way. And then I also have one that's a little bit more complex, a little more depth, and it takes a little more time. I like this one a lot because I feel that students are actually able to do more creative writing in this aspect because they're going to be creating rules. So for this scenario, it's your school's putting together a carnival for the community. Students of all ages are going to be attending, and they've asked your team to develop a launching device game that can be used for the event that would be challenging but fun for all students attending. So my ask for you today is, can you and your team create a launching device that will be safe and fun for students to play at the carnival? So again, this one's going to be a little more in-depth than the other one. They both achieve the same concept. And then I'm going to give them some constraints and criteria. I always try to incorporate some type of safety measure and talk about safety, because that's something that they're going to be using throughout their lives at work. You know, we all have to adhere to the safety rules. So giving them the power source, this is what I want you to use for your power source, but then also saying, these are some rules that I've set in place, because there's always going to be expectations set no matter what you're doing. And I use this time that I have at the bottom. It says to do it in the time frame, because we're always so limited at time. And it also helps me stay on track. So I'm always having timers on the board. So I will say to them, okay, your time frame for this lesson is you have 45 minutes. Or if this is an extended day thing, today, this is how long you have, this is where you're going to need to end up before the time is out. So the students are going to be using the rubber band as the power source. And I'm also telling them that the device has to be on the ground on a level surface, because then if they're holding it in their hand, it's shooting everywhere. It's a little more of a safety hazard. So setting that in place before is always a great way to start. And then with materials, I most of the time had picked materials that are just what I have, but occasionally you're going to need to get other types of materials. But I will say this, make sure you list everything that they're allowed to use, because We all know that there's going to be that one student that said, I can't use a pencil because it's not on the list. Just covering your bases is always a great way to approach it. And again, I have safety goggles on here because I would like to cover my back in these activities, especially if they're launching something. So this is the sketch and label, which is the planning aspect of the engineering design process. I use this time to have students just slow down. Like, we've gotten them excited. We're going through this narrative and we're getting the ask out there. But I want them to just take a second and say, okay, what am I being asked to do? And sketching out their ideas and labeling it before they can ever touch the materials. And I always say, if you don't have a reason for what you're asking for, then I can't give it to you. And that minimizes waste in your classroom as well. And again, it makes them carefully think out what they're trying to do. And then, of course, we get to the create phase where they get to build and work with their team. I try to make sure that every single student has a job, because I've noticed that there's always one or two that are like, hey, I know what I'm doing. Come on, I'll do it. And then it ends up that people are just standing by and watching. And that's never a good approach, of course. And then the testing. I personally, this is of course, my personal opinion, but I like to set up testing areas in the classroom, and you can do one per group if you want to. But to say, when you test your object or your device, you have to take it to that area. And that limits things flying all over your classroom. I also try to put together just a little easy handout that gives them the information of what I'm trying to get them to look for in their testing. So what am I asking you to look for in the test, and writing down as they work through it. So if it's how far it went, writing down that measurement and talking about how the launch was, or if they're looking for velocity, and just making sure that those are out there so while they're working, they can write down. All right, so again, I just bring back the content that I talked about at the beginning. It's still the same content and the same questions that we're wanting them to understand, but a different approach to that activity. So the same for secondary and elementary. It's the same concepts that we're trying to do. And then the share and reflection. I personally had struggled with this part because I wanted them to keep having time to build, but actually taking the time to just say, okay, talk about what worked, talk about what didn't. What were the challenges? Would you do it differently if you had the chance to try again? And then also to just get that chance to walk around the room and look at what other people came up with. And this is how I determine whether I have done a good job of making sure that their creativity is involved. And that is, if I look around the room and it's just all the same thing, it's just cookie cutter activities, then I don't feel that I was successful in my STEM activity. But if I look around the room and there's a variety of things and everyone had a different vision, then I realize that they're getting that engineering side of it. And that's often what we run into with the activity in the first lesson that I showed you. So just taking a second and thinking about activity one, the traditional one, and the STEM approach that I talked about just now, thinking about, is it student-led? Is it teacher-led? Are the students getting a choice? And if they're not, how can we alter that? So I think it is like one of the biggest struggles is people are like, okay, what is STEM? How is it different than traditional math or traditional science? And how does engineering fit in? So I know there's a lot of definitions of STEM and they vary and it's confusing sometimes, but getting a grasp on the approach to the lesson. So for the sake of our 21st century students, helping them get the chance to have real interaction and rigorous activities that make sense and that they can connect to. And of course, my activities might not be aligned to where you live. You might not ever get snow. So you don't want to use snow as an example because they're not going to relate to that. So you know your students, make the narrative come alive to them and what their interests are. And this will honestly help with the way that they approach learning. I noticed with my students, the change from just constantly worrying about what was my score on this quiz or that quiz. It was more like, okay, I can take out my creative side and really get to express myself in my learning. And then the other stuff starts to fall into place with grades. So I know that was kind of fast. I know I talk fast, but this is my chance to kind of interact with you guys. If there's questions, if there's challenges, if there's concerns, if there's something you want to add to, this is your chance to have some conversations. I do want to do a special shout out to my friend Lauren Kelly, who also is a STEM forward person. She has lots of STEM degrees, but she helped with me and writing this lesson and coming up with the concepts. So I just want to acknowledge her. And if you ever have questions, she's still in the classroom doing the work that needs to be done. So she said, if you ever have questions or you want to collaborate, that's her email address. And that's my email address. So if you have questions, feel free to and Corey, if there are questions that I missed.
Not yet. Nope. But I'll be watching the chat.
Okay. Anything for me? I'm not sure if this makes me more afraid or if it's like, okay, I made a good point. Thank you. There's nothing you want to add to it? Surely you guys have something to add. Okay, so Allison asked the question, grading. When asked to put a numeric value to the process, what advice do you have for assessment? So that's a great question, because once you're being asked to actually put in a numeric grade, that can be a little bit stressful. But I would say that's when I would bring in a rubric and there be a point system on the rubric. A lot of times I focus on not just the content, but also the collaboration. Were they making that effort? Was it there? I love it. If we're asking them to fail, let's just give them all Fs. Yeah, right. I mean, that's a learning lesson in and of itself. So I would say, yeah, that's the approach that I have done when I've been asked to put it in grades. But thankfully, when I was really just a STEM teacher, I didn't have to do that. But in my classroom, when I was teaching 5th grade, I definitely had to do that. And of course, it is frustrating because you don't want to put a grade on it because you feel like that puts pressure on them. But I really would say the rubric is a great way to go for grading. How STEM fits the state testing. Oh my goodness, you're asking me the hard questions. Okay, that's a really great question. I'm gonna stop sharing so that way I can actually see people and also see the chat better. Oh, what are my thoughts on that? So I would say one thing that I did notice is that students their confidence is increasing when they get the chance to do things like this. So that, to me, I did notice an increase in scores. Of course, it's kind of a hard approach because it's a different way of learning, right? But I did notice the confidence and the willingness to try is there, and it builds that when you incorporate STEM into your classroom. So that aspect, for sure, I feel like is one of the big things. Anyone else? Is there hard? Yeah, I'm glad. Thank you for asking the hard questions. I prefer to be challenged. And I'm definitely going to share out the information. So don't worry if you wanted that. And also, again, feel free to reach out to me if you have questions or anything. Anyone else? So if not, what about answering this question? So what would be your definition of STEM if you were going to define STEM? And you can unmute if you want to, or you can put it in the chat, but I'd be curious to know, like, what is your approach to STEM? Is the definition different for you than it is for me? And I'm sure it is, because again, everyone has their own definition, which is unfortunate, but also fortunate because we have a different approach. Okay, good lesson resources. Thank you for asking that. So I will say that when I wrote curriculum for my district, I used, let me see if I can find the book and I will share it in the chat. There's a book that I used for just the resource side of it to help get my mind thinking, because again, the creative side of it is part of it. And it is sometimes hard when you're having to think up that every single time. Let me see if I can find it. If I can't find it, then I will send it to you. Okay, so Picture Perfect STEM is one of the ones that I definitely used a lot when I was writing curriculum for the district. It's a really great one, although sometimes it's not quite what I want it to be. It gets me in the right direction. And it's still very STEM forward. So problem solving, yes, STEM is definitely problem solving. Oh, I love that. Yay. I think it's really important that we really open the door for creativity for students. Student-led activities, yes, allowing them to explore and collaborate. And it's really uncomfortable. Like, I'm not even sitting here saying, oh, it's so easy. It is 100% not easy. And it's scary to give up control in your classroom. Yeah, I struggle with that a lot, because I have like, okay, this is what I want it to look like. Why are you not headed that way? And you just want to just give them a couple ideas. But being willing to just say, okay, I'm going to just let them try is scary, So please don't think that I'm saying this as like, oh, I've got this. This is really easy. But all right, STEM's hand-on application learning, or applicable learning, yes. Problem-based learning approach to incorporate science standards, math, engineering, and technology. But every activity doesn't have to incorporate all portions. Okay, so that's a great comment that we can kind of dig into just a little bit. So if you are doing a lesson in STEM, it is not STEM if all of the aspects are not a part of it. So they're separate entities, but in STEM, they're one entity. So how do you incorporate all of those into it? And that's the problem that we keep running into. I'm going to pass it back over to Corey. I'm going to keep reading y'all's comments because I'm fascinated, because we're out of time. But I'm going to let Corey take over.
One thing that you taught me through this presentation, and you and I had talked about before, is I didn't realize that I may have been stifling creativity of my students in our makerspace by giving too much instruction and too much direction. So that is really fascinating to me, the idea of limiting that direction and letting them come up with their own ideas, like the launcher instead of the catapult, because those are two very different approaches. So I want to thank you for that, Chauntée. That was great information. Just wanted to remind everyone, again, we'll be back for the last webinar of the year on June 21st. Please look for the invitation at the beginning of the month. And then we will be back in the fall with a whole new set of webinars, a different format. We'll really be looking forward to interacting with you. We'll send out the recording and your certificate and the slides probably tomorrow in an email. So be looking for that. And with that, I want to thank you again for joining us, and we hope to see you next month.
Thanks, everyone. Thank you so much.